Hello, dear authors and invited guests. Good morning, everyone. Welcome to a technical session 3A. On the behalf of Team ICT4SD and the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 6th International Conference on ICT for Sustainable Development through Zoom. It's my great pleasure we are very thankful to everyone who present on this platform to go along with us digitally for this conference on this unpredictable COVID-19 situation and making this conference more productive. Also, we wish everyone and their families to a protected time, and we all will together pass this soon. We hope you will enjoy the knowledgeful and interactive session. Just before we get started, I would like to introduce our chair of this session, Dr. Anubha Jain. Dr. Anubha Jain is Associate Professor and Head of Department of Computer Science and IT, the IIS University, Jaipur, India. She has more than 20 years of teaching experience. Area of interest is software engineering, algorithms and data structure, programming language, information retrievals, information architecture, e-banking, and secure transaction and web applications. Thank you, ma'am. And welcome to you.
Good morning,
Good morning, ma'am.
Namaskar to everybody, all the participants here.
Now,
wish you all the best for your presentation. We can start off, Richaya.
Yeah, now there's a special note for everyone. You will be given 8 minutes for their presentation, and after 8 minutes, after 7 minutes, I will raise a gentle reminder to close your presentation and conclude. So we are very limited time, so please stick with the time. So now I would like to invite our first presenter. It's Kuduganti Sai. Is presenting paper on geospatial technology and analytic hierarchy process-based discrimination of groundwater potential zones in Vijayawada, Mangalgiri region and Andhra Pradesh.
A very good morning, everyone. Hi, could you please let me know if I'm audible to you?
Yes, you are audible.
Okay, thank you so much. Please let me know if you can see my screen.
Yes, your screen is visible.
Yeah, thank you so much. Good morning, everyone. I'm Koduganti Sai Sudha Manasa from Center for Wireless Networks and Applications, Amrita Vishwa Vidyapeetham, Amritapuri, India. Today, I'll be talking about my research topic, that is geospatial technology and analytical hierarchy process-based discrimination of groundwater potential zones in Vijayawada Mangalgiri region, Andhra Pradesh.
Dear presenter, your voice is not audible.
Okay, am I audible now?
Yes, you're audible.
Yeah, thank you so much. The contents goes with the introduction, study area, data requirements and methodology. And finally, I'll be talking about the results and discussions. Groundwater is one of the principal sources that contribute to the total annual supply. Understanding the groundwater potential zones is significant for water management and planning for any city. Situated in Andhra Pradesh, the Vijayawada Mangalgiri region is majorly known for its industrial and agricultural activities. However, the rapid urbanization, inappropriate land use methods, increased anthropogenic activities, and poor irrigation practices led to the depletion of groundwater during the last few years. This research helps in discriminating the groundwater potential zones using a combination of geospatial technology, that is remote sensing, and GIS, which we call as Geographic Information Systems, and analytical hierarchy process, which augment the source of groundwater. Different thematic layers such as digital elevation model, drainage density, slope, soil type, land use, land cover, and rainfall pattern were prepared and analyzed by employing primary and secondary sources. The weighted overlay analysis has been performed on various thematic layers based on their importance using AHP. A groundwater potential map with 5 zones has been classified as poor, fair, good, very good, and excellent. Coming to the study area, here comes the map which shows my study area, mainly concentrating the Vijayawada Mangalagiri region of Andhra Pradesh. Encircled by the hills of Eastern Ghats and canals, the Vijayawada Mangalagiri region in Andhra Pradesh sprawls on the banks of the Krishna River. Telugu is the predominant language spoken by the residents of the study area. Having a tropical climate, the annual mean temperature range from 23.4 to 34 degrees centigrade. The summers have more rainfall when compared with winter, and the annual rainfall ranges from 900 mm to 1100 mm. The broad range of land use practices in the study area includes settlements, agriculture, barren land, and forests. The major soil types in the region are loam, clay loam, sandy loam, and clay. Coming to the data requirements, the study was pursued by taking into consideration various layers, say drainage density, elevation, slope, soil, land use, land cover, and rainfall. These data sets have been composed for various primary and secondary sources and are redefined in the geospatial environment to create the database. The shapefile layer of India was obtained from DivaGIS, an online repository for GIS data. Digital elevation model is extracted from the Astro Global Digital Elevation Model version 3 to prepare the slope, elevation, and drainage density layers. Also, the cloud-free Sentinel-2 dataset, which is of 10-meter resolution, has been chosen for performing random forest classification for land use land cover extraction using one of the cloud environment tools, Google Earth Engine. The rainfall data in grid format has been downloaded from the Climate Research Unit. Talking about the methodology, here comes a methodology which shows the remote sensing data, that is the Sentinel-2, which is used to extract the land use land cover information, and also different layers like rainfall, soil, digital elevation model were used. From digital elevation model, the elevation slope and the drainage density layers were extracted. Also, all these input layers were given to the analytical hierarchy process, wherein we'll be talking about the consistency ratio. That is, the error should be less than 0.1. That is 10% of the overall information. The maximum error that can happen is 10%. So based on that, each layer is assigned influence, and the weights, based on the weights, we'll be doing overlay analysis. And based on that, the groundwater potential zones of Vijayawada Mangalagiri region has been acquired. This total methodology comes under the geospatial techniques, that is using the remote sensing and GIS data. Talking about the analysis of results, the first one is the drainage density. It was achieved by computing the flow direction and flow accumulation of the region and thereby clustered into 5 classes, starting from 0.9 to 5.7. From the drainage density map, it was observed that the elevated drainage density is due to less infiltration and doesn't endorse the potential zones of groundwater. The depressed drainage density is due to high infiltration and indicates groundwater potential zone. Another layer is the soil. Soil types play a crucial role in the water quantity that can infiltrate into the subsurface and thereby affect the recharge of groundwater. The Vijayawada Mangalagiri region includes different soil types such as loam, clay loam, sandy clay loam, and clay, which can be shown in the map. The elevation signifies the undulations of the ground surface available for sink storage. The study area elevation ranges from 8 to 326 meters of mean sea level. Also, the slope is a vital terrain feature that signifies the ground surface steepness. The slope of the region affects the rate of infiltration and surface runoff. A steeper slope indicates the higher runoff. Another data set is the rainfall. The rate of infiltration depends on the amount and the period of rainfall. The data acquired is from 2020, which is used for the study, and the annual rainfall ranges from 948 mm to 1075 mm. The rainfall spatial distribution map was developed using the Kriging interpolation techniques. And finally, the land use land cover. The study area has been classified into 5 major classes, which include water, agriculture, settlements, barren land, and scrublands. As you can see, all the blue color portion is the water, yellow is the agriculture area, red is the settlements, and light brown is barren land, and green is the scrubland. So this is the distribution of different land use land cover classes in Vijayawada Mangalagiri region. And the highland area is comprised primarily of scrub forests. The midlands and lowlands are dominated significantly by agricultural land and settlements. The high weight is assigned to the water, agriculture, and the low weight is assigned to the settlements, barren land, and scrub forests, because the major concentration is groundwater potential zones. That's why the high weight is assigned to the water. Analysis of groundwater potential zones. All these 6 data sets were generated in the geospatial environment, and the suitable weights have been determined by the analytical hierarchy process technique. The weights for each thematic layer were selected based on the SATIS scale on a scale of 1 to 9 of relevant importance. So based on the value, it can be 1, 3, 5, 7, 9, and 2, 4, 6, 8.
Sorry to interrupt. Your last 1 minute.
Yeah, okay. Thank you so much. So based on all these values, the groundwater potential zones were analyzed. And also to generate these layers, we use all these thematic layers with the groundwater potential zone generations by assigning different weights to each layer and different ranks, and based on their priority, we'll be giving the percentage of weight for each layer. Finally, this is the groundwater potential zones, which we can see the red portion indicates the poor groundwater, and similarly green goes to the excellent. And we can see the area distribution. The excellent groundwater potential zones is hard, that is only 0.0099 kilometers. So finally, the conclusion. The geospatial technology involving remote sensing and GIS helps in deriving spatial and visual results more prominently. The present study discriminates the potential zones of groundwater using geospatial technology and analytical hierarchy process in the Vijayawada Mangalagiri region of Andhra Pradesh. A total of 6 thematic layers, including digital elevation model, drainage density, soil type, slope, land use, land cover, rainfall pattern was used in the study, and appropriate weights are assigned to all the layers. The output map shows 5 categories of groundwater potential zones as poor, fair, good, very good, and excellent. The very good and excellent zones are situations in and around the Vijayawada city, and poor zones are situated in and around Mangalagiri. So this shows the special attention in the Mangalagiri region needs to be given to recharge the groundwater. All these poor and excellent groundwater potential zones covers less than 1% of total area, and fair covers an area of 26.44%. Also, good groundwater potential zone covers area of 53.12 and so on. So finally, the potential zones map of groundwater in the current research contributes insights for decision makers for groundwater management and planning agricultural and industrial activities. Thank you so much. Stay safe, get vaccinated. Yeah, if you have any questions, please.
Yeah. Can you hear me?
Yes, yes.
Can you just come to your conclusion slide?
Yeah.
First question that I have for you is, how were you able to arrange the data of this satellite pictures?
Sorry, I mean, could you
Basically,
please
where
bit
did you
louder?
get the data? Yeah, where did you get the data set from? Am I audible to you?
Hello?
Yeah, am I audible to you?
Yeah. Sorry, I couldn't hear you.
I'm just asking that how were you able to arrange your data set?
Okay, yes. Mainly the required shapefile of the area has been downloaded from the VGIS and online repository. The Sentinel-2 dataset has been downloaded from the Google Earth Engine, and initial pre-processing has been done in that. And from the Sentinel-2 dataset, I have prepared the digital, the digital elevation model has been downloaded from Google Earth, USGS Earth Explorer. And from that layer, I have done the slope, elevation and all. So all these layers were used to create a geodatabase in one of the softwares, that is ArcGIS Pro. And from there, each layer has been taken for processing and the weights are assigned based on their importance for the given study area. So my concentration is groundwater potential zone. So I have given majorly the weight for water layer and also to the layers which require the water like agriculture and the forest. And the remaining urban settlements and barren land doesn't require any water component to be in there, so the priority will be less. So
yeah. Okay, thank you very much.
yeah, thank you.
Very nice presentation. Thank you. Maybe
Thank
we can
you.
move to next.
Okay, so can I close this?
Sure.
Yeah, thank you so much. Thank you so much, everyone.
Thank you so much, presenter, for your nice presentation. Now we can call our next presenter, Vishal, for presenting his paper on a trade cloud ecosystem structure for shared learning.
Hello, good morning to all. Am I audible?
Yes, you're audible. Please, you may start
Yes.
your presentation.
Yes, I'm just sharing the screen. Wait a second. Yes. Is my screen is visible to all?
Yes, it's visible.
Yes. Okay. Good morning, all of you. So my work, we are working on the on-trade cloud ecosystem structure for shared learning, right? So it's basically is an current scenario, whatever we are having, right? So it will be based on that. So let us see the contents. So we are moving towards abstract introduction, and we will be making first of all what do you mean by the collaborative learning, what are the different proposed methodology we have suggested, we have implemented, and the result section in which we will see how exactly it will be worked, right? And after that, the conclusion and the references we will see. So let us start with the abstraction, right? So if you, as all we know that nowadays cloud computing is in, you can say that the booming field, right, in the booming domain in which obviously it will be rapidly increasing day by day, right? So we proposed an implementation of cloud ecosystem for shared learning to explore the uses of the infrastructure platform as well as software as a service in our education domain itself, right? So it is nothing but an ICT based you can say the system we have made. So in this system what we have what we have done exactly, so whatever the staff or the faculties is having in any institute or any university or any you can say that in any colleges, right? So in that we are just trying to make reduce their work in terms of the laboratory setup and all that things. Because if you see for any kind of the subject in any kind of the laboratory subject, right, in each of the semester, in each of the academic year, they are having their own you can say set up the tools, right, for each and every subjects, right? So we are making such kind of the system in which it will be very easy for them, for that particular laboratory, you can say that staff or you can say that lab assistant or teaching assistant, in order to set up all these things for their students, right? So here we are allowing that particular to access these cloud over the web for the shared learning, so as to call the required application program with respect to various subject groups together as and when required, right? So what we are going to do, I just explain you in the later of slides, right? Yes. So in introduction part, if you see, we are using here the all the three AAS, PaaS, and the SaaS. You can say the service models of the cloud, right? So AAS is nothing but infrastructure as a service. It will gives you all the infrastructure components like virtualization, disk, networking, computation, and all that. This, right? So if you see in nowadays a very popular one, that is AWS, you can say that it is an AAS example. Then with respect to the past, it gives us a virtual machine environment advancement, right? So obviously any kind of the client, he can directly design and launch different software on that particular cloud environment, right? So here example I've given here the GCP as well, right? And the SaaS, that is software as a service in this. obviously we are directly utilizing using that particular software, right? So like you can daily basis you are using your Gmail, right? So that is one of the example of your software as a service, right? So in which how this collaborative learning we are going to be implemented, right? So if you see here, it is nothing but a teaching and learning which includes the different students group working all together to resolve all the common problems which students are facing, right? To students are completing a task or create a final solution of the product, right? So whatever they are going to do in their subjects lab session, right, that they needs to be do on this particular collaborative learning platform, whatever we are doing, right? So in this, if we see why there is a requirement for such a platform, right? So here, if you say one of the problem in our education field, in each of the semester for every of the class, right, there is a need to set up labs which will be manually, right? Obviously it will be depending upon subject to subject, depending upon to software tools to software tools, right? Because for every subject, obviously teaching methodology is different, teaching different tools are the different, and obviously it will be based on your semester to semester, right? But here what happened that whenever the lab in charges or teaching lab assistant, teaching assistant is going to be set up all the labs which will be required, all the softwares and prerequisite, all the software which will be prerequisite for, if you see every new batches for every new lab, right? And that particular subject which will be not same for each of the faculty, because obviously the teaching load is going to be changed in each of the semester for that particular faculty, right? So here there is an one problem with that particular lab in charges, because he needs to set up all the things again in each of the semester to again different set of the faculties, right? So here we are giving here the solution in terms of the SaaS on demand service cloud computing. We are able to use it to overcome this issue and give collaborative hassle-free platform for faculty members and as well as for the students, right? To do the lab exercise without wasting time for the installation and configuration. So students can get directly all the application is ready-madely installed in their desk, right? So they can directly use on-demand application or software by just clicking on icons of that particular software, which will be already installed in their login, right? So let us see how we have done these particular systems, right? So we have the built one you can say server virtualization, that is Zen server in our own college campuses, right? This method whatever we have proposing that are tested, that are set up already, and that are already we are using, right? So here we have set up Zen virtualization. On Zen virtualization we are using this open Zen manager, which is an open source tool in
Dear
order to
presenter, sorry to interrupt. You have last 1 minute.
okay, in order to use that particular Zen server, then we are using this Altio tool as a software as a service in order to use that particular client and server application, right? So in server side, what we can do, we can generate all the application, we can create all the application, and through client side they can all the students can access that in their own login, right? So that is basically the, and if you see here one case study I have explained, we have done that, that is second year, third year, and BE students, right? So in which are having all the 60 capacity, right? So obviously for each semester they are having different subjects and all these things. So we have set up the things for them. So I just directly go with the result. So if you see in admin panel, so we have created here different number of users and different number of application groups, right? According to the different classes, we have set up different application group over here, and we had just mapping all the this group user groups to this particular application group over here, right? So that all the so if you see, these are nothing but the application group, right? And previously these are nothing but the user groups, and both are mapping with each other. And when your client side, when student is logging to their account, right, obviously whatever the software or applications we are mapped to his or her group, that will be available in his or her login, right? So this is basically our cloud based solution. So in this conclusion, so if you see, by using this platform, we can work spread out more in the laboratory instead of all the time installing software every time, right? So obviously the student is also getting more time in order to perform in the lab, in order to just stuck in the installation procedures and all that things, right? And obviously the staff, the faculty member is also getting much of the time to do extra things to lab improvement and lab enhancement thing, in order to just concentrating on the installation and configuration setup, right? So these are the references we have gone through, and Thank you. Thank you for listening.
Hello.
Hello. Yes, ma'am.
Yeah, very nice presentation.
Yes,
Sir,
thank you.
can you just elaborate a little more on how does cloud help you in collaborative learning of the students? Is it due to the reason of the
Yes.
projects being given, or is it just in general?
No, ma'am. Here we have targeting the both the things, right? We can also assign the projects to the students, because when we are assigning the projects, obviously we are creating some user group of that particular 3 to 4 students, and we can assign them one assignments. And also we can, at the admin side, we have the rights to you can say to monitor all their performances as well, right? So that way we are doing all the collaborations over here, ma'am.
How does it help in individual assignments? Like we have a manual lab and we have a cloud-based lab. What is the difference when we give individual assignments?
Yes. Yes, ma'am. In nowadays, if you see in systems, whatever, for example, one practical session is there, and after the practical session, all the files and folders of that particular student is there in their, you can say that on that particular desktop itself, right? But here in the cloud based, the student is getting all the personalized all the things, right? Login and credential. There is some security over there for all the students, and whatever the stuff he or she is doing, it will be there in itself in their login itself, right? And obviously the faculty who is in charge for that particular lab, he is going to access all the things over there for all the students. So in this way it will be useful, man.
Okay, thank you, sir.
Yeah, thank you, man.
Thank you, Vishal, for your presentation. Now we can call our next presenter, Lee, for presenting his paper on mobile. You may start your presentation, please.
Sorry, good morning. I'm just double checking. Can you see my presentation screen?
Yes.
Okay. Good morning. My name is Lee McQuire, and I will presenting you mobile deployment measurement of RF man-made noise by making use of RTL SDR. My co-authors was Mohammed Khan and Dr. Vipin. Can we just get this? Yeah. So basically, a background of it is, spectrum is a limited resource, and unfortunately, there is not enough spectrum going around, especially with newer technologies coming into the system. So we need to make use of our RF currently more efficiently and find better ways of using the current system. Um, Basically, to optimize spectrum, we make use of spectrum monitoring. Now, spectrum monitoring is like the eye and ears of the monitoring system. And when we do radio monitoring, we look at RF, how much RF noise is generated, and we try to monitor what's actually happening in the air from a regulatory point of view. We monitor these frequencies by making use of monitoring sites. Unfortunately, these monitoring sites has got they are relatively expensive to build, and they are very limited in coverage in how much area they can actually cover and in the frequency range which they are. And to optimize them and to change them is quite expensive, especially for developing countries. My proposed solution was to install a low-cost monitoring system on portable vehicles, and by installing the system onto the vehicles, you'll be able to collect information, as the vehicle moves. Um, the system will basically configure of, your RF part of it, which is your antennas, they going into your equipment that can actually read the information. This will be processed by a computer, and with GPS logging, you will be able to log wherever the information was collected and pre-processed obviously by a PC an internet connection if needed, if you want to externally access your device. This system that I'm proposing will opportunistically collect information. So as the system moves, you'll be able to, in urban areas, make use of the taxis, buses, and so forth to collect information. And in rural areas, use long distance transport to actually measure this information. And in this way, you'll be able to get information, or RF measurements that you would not easily be able to get in the past, especially if there's rural areas, because it does not make sense to build a monitoring site for very rural areas. Some of the objectives that I identified within this project was to make the system as cost effective as possible. And in this, I need to be able to obtain accurate and minimum results, increase the capability of the system to detect, hopefully be able to reduce the noise flow. And, because it's fitted on different vehicles, I need to make space for noise differences that I might get in our environment. Yes, and combining all this information in specific time and place. So my proposed system, what I did was I used basically external antenna. I connected it to filters and bypass how can I say, filters and LNAs, and this basically gets driven by a software-defined radio, a cheap, inexpensive device that you can get off the shelf. I combined this with a computer. In two scenarios I had, where the one was using a standard computer and the other one was using a Raspberry Pi, basically making the system very cost effective. And this is just fed by a standard antenna, omnidirectional antenna for the frequency band. This information will be recorded onto a database and later on be accessed by a PC or via the internet. Okay. So one of the other objectives that I saw was when I installed the system onto PC, the Raspberry Pi itself and the computer itself had internal noise, which actually raised the noise flare, and this caused quite significant errors within my measurements. So what I tried was I basically one of the things and the other things I was found the vehicle in itself, because we be putting the system to different vehicles. These vehicles all create their own RF noise flow, which fluctuates between what's going on in the vehicle and who is participating in the vehicle. One of the ways I actually tried to bypass this and was taking a pre-recording when the vehicle is on, when the aircon is on, when the electronics is on, and when the RF monitoring system is running fully. I recorded all the information and I used this to imprint over the others to cancel out the information. And I also add the extra 10 dBs of guard band so that we can know whatever we are measuring is not errors that is being created by the system. The second one I identified was I needed to cut down the cost, and one of the ways that cut down the cost was by making this data storage needs less. Now, this system is installed the plan is installed in public transport. Now, unfortunately, public transport, we don't have the speed that it will be traveling. We don't know how long it will stop and so forth. So one of the ways I approached this was actually by making use of selective sampling. Now, what I did with selective sampling is that as the vehicle moves, it covers a certain amount of distance. So what the plan was basically to take that information over the planned distance and then average it.
Sorry to interrupt, dear presenter. You have last 1 minute.
Sorry, can you hear me?
You have last 1 minute.
Okay. Sorry, are you talking to me? Sorry. Hello. So okay, so what I did was I used the selective sampling, and as the vehicle moves, to cut down data storage, I only took the average of the collected RF levels or IQ data for a specific distance, and this was making use by Elian methods and as I did that, it actually helped to significantly reduce the amount of storage that I needed to be able to record the information. And this information could then be plotted with the specific data that I acquired. Um, some of the objectives, when I did my pilot test on it, I monitored one of the radio stations in Malmö, South Africa, and this was done in December 2020. I used MATLAB to actually monitor this information. And in this, I on the frequency that of interest that was 101 megahertz. The noise flow that I measured in the pre-testing of the noise flow, the noise flow level I got was 26.6 dBm. That was measured. And as I took a 5 dBs above the equipment noise floor just before the error rate, just to correct the error, I actually got a saving by just taking that information away. I got a 31% saving in data space. Then by adding on the selective sampling as I drove with my vehicle, I actually got a 60% reduction within my storage needs. So as you can see, there's some of the example of the information I got. I got a scatter plot prediction of the radio station. You can see with red being, where it's higher, the RF signal is higher, blue being lower. And I used natural neighbor interpolation just to make a basic prediction of how the coverage is. The interesting scenario with this specific recording was, this radio station was actually transmitting in an area where it wasn't supposed to. After further investigation, I actually found out that this radio station turned the transmitter in the wrong direction and was actually overpowering the system. So, with some mitigation and, enforcing against them, we got them to correct it. So actually the system actually picked up one of the illegal users without even knowing it. Yeah. And with the system, with the occupation measurement, data use spectrum regulation, we can help with allocation.
Sorry to interrupt, dear presenter. You
Yes,
have
please.
only last 1 minute. Please conclude your presentation.
Okay. So basically, you can see all the advantages that will come from it. It will help us use spectrum more efficiently. The proposed system is a very cost-effective means to actually collect the information. With selective sampling and with cancelling out the noise, we'll be able to get to the end, or to get the information more condensed, and so the unit can be out in the field for longer periods of time. With the system, it will help the regulator to enforce better and will assist with protect the regulation, RF spectrum as currently used and current users of the RF spectrum at the moment. Thank you. Sorry for that.
Yeah. Am I audible?
Any questions?
Yeah. Can you hear me?
Yes, I can.
Yeah. Have you implemented this module, or it is just a proposed module for you?
Actually, I did implement it. This results that you see on the slide was actually real results that I actually got. This is active results as I monitored one of the radio stations in our area. So it wasn't proposed, it was actually implemented. The plan is basically to,
What is your plan, future plans for this model? It's a very good model. I must congratulate you. But what are your future plans for this model?
First scenario will to put it onto our working vehicles just to see how much information we can collect as we're driving. And thereafter, maybe is approaching one of the public transport just to put the unit in, because the unit is nice. You can it's basically just plug and play. And at the moment, I don't have an internet connection to it, but it will still be able to record quite a significant amount of data, leave it there for 2 weeks, come back to the vehicle, take it out, copy it to your PC. And then at the end of the day, as this model will grow, and you add more vehicles to the system, you'll be able to get a very nice plot of actually what's happening out in the RF market, what is happening in the field.
Right. And have you thought about or planned about that as the data grows for your model? How will you manage it?
Obviously, as the data will grow, obviously it will be all the data is saved in CSV files currently. This will be exported to SQL database, and probably using a little bit of, I actually haven't thought, to be honest with you, I actually haven't thought of what if the data gets too much. Probably use one of the, big data methods to actually basically, incorporate this information so it'd be easily accessible. So you can go through a timeline and actually see how the RF environment has changed over time.
Right. Okay, thank you.
Thank you.
Now we can call our next presenter. Prashant Watts, for presenting his paper on a hybrid approach for retrieving geographic information in wireless environment using indexing techniques.
Ma'am, very warm good morning to all of you. Am I audible?
Yes, you are audible.
Okay, ma'am. Just give me a second, please. So is this screen is visible to you, ma'am?
Yes, it's visible.
Very warm good morning to all of you, to the session chair as well. My name is Dr. Prashant Watts. Today I'm here to present my paper on a hybrid approach for retrieving geographical information in your wireless environment using your indexing technique. So the basic idea behind this paper was to basically see that nowadays we have seen that wireless data transmission technique, they have actually emerged as a you can say residential data distribution process in which basically they are used for the dissemination of your public users in order to cater a large number of mobile users. So in this research paper, we have basically proposed an hybrid, you can say, indexing technique for the data transmission, which will be based on the dispersion of indexing using your hash table with the Huffman tree indexing, tree index coding. So in our proposed work, what we have basically done is we have actually theoretically explained the performance of existing indexing technique under a detailed study. And afterwards, we have compared their performances, and then we have used the indexing technology with your Huffman coding to basically retrieve various geographical information in your wireless environment. This proposed technology we have evaluated in terms of time efficiency, time difficulty and efficiency both. And it has proved to be very efficient during our experimental analysis. So first of all, I would like to begin with the introduction at what this wireless indexing technique is all about. So see,
sorry to interrupt, dear presenter.
Yes,
you have only 8 minutes for presentation. So please speed up your presentation.
Sure. And basically what happens whenever we see something on your GPS, or you can say you start your Google map and all that. So what basically you see that some data locations are available to you. Now, how does this happen? So basically what these network nodes they have in their wireless information. So basically they have data related to the users, which is basically based on the geographical based informational data that has been stored in the electronic library and record archive. So which basically is affixed to some internet pages that has been used with the details of the location of your web page text. Suppose if I want to surf about something in my nearby location, and when I go with that GPS location, or you can say using that wireless technology, I want to locate, then I get the locations of those places and how those locations are actually been you can say put it in that. So that is through with this wireless indexing technique. So basically geographical locations, they are plugged with your internet document. So that is being used for the geographical information recuperation systems. So I will come to directly with the study that we have done. So basically we have studied the 3 wireless indexing techniques in which we have studied about the hashing schemes, B+tree based schemes, and the Huffman wood compression based scheme. So hash scheme that we have seen, they have basically used you can say less power, and they have a shorter transmission range and shorter access time. They can also connect errors with your flexibility. In this case, where most customers need short comeback time and minimal power consumption, then this hash scheme can be used. Then we have your B+tree schemes, in which we have implementation of databases where B+ contains pointers to your or lower level nodes in the tree, and you have an ordered list of keys. Further, we have this Huffman wood compression based scheme in which we have basically a small index tree that considers the potential for your data entry, where most popular data will be accessed from root to path with a shorter route, so that reduces your moderate adjustment period. It basically works better in cases where the search is based on your contract probability and small index boxes, and it also uses less energy, and it also sometimes connects your false flexibly. So related work, this we have studied, in which we have also studied the work done by various researchers in this area. So this was the proposed work, in basically which we have used the Huffman tree indexing for your this geographical indexing technique, in which we have basically uh, done 3 stages, in which first of all we have considered the binary Huffman tree nodes, where we have considered nodes as di and dj, in which candidate will be unified, and then we are creating the you can say, based on the data frequency, we are calculating the total sum of your nodes for your di and dj with the data item frequencies, and then we will replace these nodes by new data nodes by constructing their sequences in the this HTD index. Further, we will at stage 2, what we will do, we will access and observe the each level of your node at your T node point, which will be a root node, which will be at level 1. Then considering from the bottom to your root level, this HTD index for each level, we will arrange the repointers in such a way that the left two most nodes of your Huffman tree would have the same parent and next two. So in
Sorry
this
to
case,
interrupt, sir. You have last 1 minute.
okay, sir. Okay, so basically I'm coming to this. Suppose this is my data item key with a frequency of appearance of my data. Then what I will do, I will apply my algorithm that is based on your Huffman tree coding algorithm for the indexing technique. So my whole structure will come like this based on my frequency of access of the data items on your any geographical location that you have been available to. Then by summing up from bottom to the root node, by summing up their frequencies and replicating their parts and non-replicated parts, by segregating into the two you can say area portions, we will get this type of tree. Then based on your this Huffman tree indexing, the broadcast sequence that we will obtain for your data set would appear like somewhat like this. Further, the algorithm that we have used for the retrieving data for your broadcast sequence based on your Huffman tree based index is this, in which we have conducted the experimental result that the system we have implemented with your AMD Ryzen computer with 8 GB memory and Java NetBeans and your Windows 10 version 6.1 operating system. So with using a single broadcast channel, we have simulated a base station that would, you can say, broadcasting a data collection archive with your around 10,000 data items. So this was the results that we have used, obtained as a on your network simulator. So in conclusion, what the in and I can say that we have proposed basically a hybrid indexing technique for your data transmission based on your dispersion of indexing using your hash table with Huffman tree index coding. So in our proposed work, we have basically theoretically explained the performance of your existing indexing scheme with a detailed study. And afterwards, we have compared their performances. And in our proposed approach, we have basically use this technology for retrieving geographical information in your wireless environment based on your wavelet root data structure for your text indexing and spatial data indexing, thereby establishing a new evaluation strategy. And afterwards, by analyzing each scheme under your controlled environment and with a selected criteria, our simulation results have given these two advantages. First of all, it has reduced the response time significantly, and it has proven to be more energy efficient as compared to the other schemes. So these are the references that we have used. Now, if you have any question, then please ask. Am I audible to you, ma'am?
Yes, sir, you are.
Please, ma'am.
Yeah. So can you just go on your experimentation slide?
Yes, ma'am. This was the experiment. This was the experimental result that we have obtained.
Okay. Previous slide.
This one.
Yeah. So just can you tell me why did you select Huffman coding for this?
Ma'am, Huffman coding we have selected because uh, the probability of reducing errors was less in this, plus it was less time consuming. So during our research paper, what we have seen in the past research papers, that Huffman coding, that work basically related to the Huffman coding has done on a lesser part. You can say the most researchers, they have used other coding, the indexing like your B plus indexing. They have done numerous things. In this area is still needed to be explored. As a future work, we can expand this study for larger network. Basically, this area, in this, the area was limited to a specific region. You can say to a specific area, like in Delhi, if you have northwest, southwest Delhi, South Delhi. So we have conducted the study related to something, you can say portion that are relating to South Delhi only. We haven't studied the area, this particular technique right now in a larger extent. So it is under still, you can say, what I can say, the preliminary stages, the it can be expanded further, ma'am. So yes, I can say that.
Okay, okay, sir. Thank you.
Thank you, ma'am. Thank you so much. So can I stop my sharing of this screen with you?
Yes, sir.
Okay, thank you, ma'am. Thank you for your time. Thank you so much.
Now move ahead. We call our next presenter. Sir T. Milton, to present his paper on a meta-analysis on online classes for hotel management studies at Chennai during COVID-19. Dear presenter. You may please start your presentation.
Is the screen visible, ma'am?
Yes, it's visible.
So, good morning, chairpersons and all the academicians. My research paper is on meta-analysis on online classes for hotel management students at Chennai during COVID-19. Okay, I am Dr. T. Milton from Bharat Institute of Higher Education Research, Chennai. The agenda: introduction in online classes, impact on hotel management education, methodology, results and discussion, a discussion on teaching and learning, and conclusion. Introduction. Due to COVID-19, the teaching through online classes has taken the place of regular classroom teaching. Many hotel management colleges in Chennai during COVID conducted classes in Google Meet, Zoom platform, WebEx, Google Classroom modes to facilitate students and learn and participate from home. The impact of online teaching for hotel management students is a combination of results. Few have responded that this method is easy to understand, whereas others say face-to-face teaching, particularly for hotel management, it is very much essential, can't be replaced with online classes. In hotel management, students need to have hands-on training sessions as this course is practical oriented. Online classes impact on hotel management education. Hotel management education provides a professional career for hotel management students as administrators in hotels, restaurants, executive chefs, and also as entrepreneurs. The course is designed in such a way where a student can learn 60% skills by practicals in food and beverage. For example, they have to learn the art of making cocktails, mocktails, how to do the service, and food production, the art of cooking, cookery dishes, bakery dishes, and other cold dishes, and Indian cuisine, South Indian cuisine. Everything has to be taught in the practical classrooms. Housekeeping, you have to learn about the floor arrangement, cleaning modes, and towel art, and other decorations, how to do that, and front office, how to deal with the guests, reservation, registration, cashiering, back office, and the rest you need to learn by theory classes. Learning every day is very important for students, as hotel management is a professional course where students have to learn the basic technical skills and soft skills required for the hotel industry, as well as constantly they need to update with the latest trends happening in the hotels. COVID situation has posed a big difficulty for the educator as well as the learner. The condition is dynamic, though it is necessary to come with proper solutions. The methodology is research is initiated with a quantity questionnaire by Google Forms having the variables of online teaching. Questionnaire is circulated among the Hotel Management College students of Chennai City like Assam Nagar College, Mohammed Sadat, Bharat University, SRM College. Then we have Wales University and Bhaktavachalam other colleges. Data were received from Hotel students of various institutes and universities of Chennai. Out of 380 responses, only 315 responses were valid and used for this analysis. To understand the students' participation at online classes and to find out the desire with apps in comparison to the traditional teaching methods was the main objective. The mean statistics is done to know the usage on social media applications. Further, a correlation is carried out to distinguish the relationship along the linear regression to recognize the strength of variables. Results and discussion. A comprehensive analysis carried out to know the Hotel Management students' curiosity on online application for studies and also to recognize their wish on learning with teaching methods in order to offer a precise as well as sophisticated teaching method. The mean statistics done to classify the collection of data with the average numbers or value to know the probability with the entire data along with the standard deviation for the acceptance on SMA about the online apps used for teaching in education institution and further on knowing the preferred app. Mean on online class acceptance with SMA. There is a mean value of 3.8819 with a standard deviation of 0.32346 for the usage of YouTube among social media apps. Around 237 students opted from the total number of 315 responses. However, some students also opted WhatsApp as a preferred social media app for studies with a mean value of 3.8462 and a standard deviation of 3.36314. The mean on online class acceptance with the teaching app used. The Zoom application with a mean value of 3.9331 and standard deviation 0.35405 evidences the usage of significantly for teaching. In addition, Google Meet is also used apart from Zoom. Google Meet now also Zoom only we are going. In addition, Google Meet is also used for the same purpose through a mean value of 3.326 standard deviation of 0.47519. Mean on favorite app used by students. YouTube videos. Since it's a practical professional course, a lot of practical sessions are conducted in YouTube videos, so it is easy for the students to comprehend. So YouTube videos are having a mean value of 3.8538 and a standard deviation of 0.35405. The number of preference 253 out of 315 responses. There is no doubt that YouTube becomes students' favorite choice in learning in terms of hotel management, catering management for practical classes. Correlation has a greater significance for practicals in offline class with the correlation value of R is equal to 0.571 and the significant value of P is equal to 0.0. This study results also shows a correlation value of R is equal to minus 3.0 with the significant value of P is equal to 0.00 for a variable online exams and online class acceptance. The time spent on attending online classes shows a sturdier correlation value R is equal to minus 3.326 and the significant value of P is equal to 0.00 for a negative association. There is a negative association for attending practical through online with a good correlation value R is equal to minus 0.230 and the significant value P is equal to 0.00. Linear regression, the coefficients value with the dependent variable as V is equal to minus 0.188, P is equal to 0.00 for time spent by students of hotel management is little negatively associated with online class acceptance. It proves that some students are not able to participate completely. In addition to that, participation in online exams has a value of B is equal to minus 0.199 and P is equal to 0.00 signifies a minimum difficulty in participation. And further, the coefficient app comfort is positively associated with the value of B is equal to 0.123. P is equal to 0.034 as Google Meet and Zoom app is more comfortable in online classes. To know the issues faced by the students, a coefficient issue in online class negatively associated with the acceptance of online class with the value of B is equal to minus 0.413, P is equal to 0.509. The outcome of regression shows a clear evidence on issues faced by the students on online classes. Correlation with the variables of online education. The investigations are showing that the data.
Sorry to interrupt the presenter. You have last 1 minute.
Okay. And online discussion is carried out to know the difficulties of teaching and learning with selective faculties and students in light of perceptions towards internet education for particular students. Some of the students have shown feeble and less participant in internet classes which genuinely confine their learning ability. Online education, the teaching faculties have fewer command and control of students as a class connected with internet and students are bound to avoid the class. Consequently, the advancement of web-based instructing in its learning adequacy generally rely upon the quality of interest in individual student, whereas in traditional classes, student can be controlled in front easily. The conclusion is there are various views on online education, especially during contagion-19 situation, although it's the best tool for educating students at the home, which also motivates them for a better prospect rather than being idle with the stress and anxiety by thinking about their education in future. There are some barriers identified through the outcome Though outcome of this meta-analysis indicates the impact of online classes for hotel management students of Chennai. Nevertheless, teachers and students are not fully accustomed to the online mode of classes for practical, especially. Students are focused towards learning subject through practical courses as they belong to hotel management professional. Thank you so much. I've finished my presentation, sir. Hello.
Hello.
Hello. I have finished my presentation, ma'am.
Yeah, just ask to chair. Ma'am, you have any question?
Yeah. Just a minute. Can you hear me? Hello.
Yes, ma'am.
Yeah. Sir, can you go on your conclusion slide once?
This is the conclusion slide, ma'am.
So there is one suggestion to you that the work done by you is very good, but if you could have presented it graphically, it would have been more understandable, isn't it?
Yes, ma'am. Sure, ma'am. Next time I'll try.
Actually, you are trying to give a study on different platforms, and you have used linear regression also, and you have talked about negative, positive. That is very good. But if it would have been depicted graphically, the picture would have been clear more. And we could have seen the comparative chart in a single slide.
I understand. The next time I'll do that. This time.
That's it. Thank you.
Thank you.
Okay, so now we can call our next presenter, Shweta, to present her paper on performance analysis of Gujarati script recognition using multi-classes and multi-label classification.
Hello, good morning, ma'am. Am I audible?
Yes, you're audible. You may please start your presentation.
Yes. Ma'am, is my screen visible?
Yes.
So, good morning all. Our title for presentation is Performance Analysis of Gujarati Script Recognition using Multi-Class and Multi-Level Classification for ICT4SD 2021. It is prepared by me, my fellow mate Q Zaveri, and Professor Sarosh Dastoor. So this is the flow of our presentation. Introduction. On Indian script, there is no accurate and robust OCR systems available for Indian languages. OCR is basically used to classify optical patterns corresponding to alphanumeric or other characters. It is used to identify the characters in an image. And for many Indian languages, such OCR systems have been developed, but for a native script like Gujarati, there has not been done any concrete work, and much of the research work is still going on. So with the advent of availability of high data processing power, we took up this opportunity and implemented and experimented with convolution neural networks to build an OCR system for Gujarati language. So what motivated us towards this is the common application of text to speech that is observed nowadays, which is also available in various languages. But for native languages, no such concrete system has been developed. So this has motivated us to do this project. This is a literature survey. What common technique we have observed in all OCR systems is the usage of CNNs for classifying the characters and the multi-class classification technique to separately classify all the characters of the data set. In many of the research papers, different inbuilt Pre-trained models like DenseNet, ResNet, VCGNet have been used, but with only the common approach of multi-class classification. But due to the cumbersome data set available in Gujarati, multi-class classification can become a bit more computationally expensive. So we thought to move to another approach, which is multi-level classification, which has not been so far used for any of the OCR system. But looking at our data set, we came to know that this approach can also be applied to reduce the time complexity of the project. So our problem statement basically is to classify and recognize all the Gujarati characters with its consonants and vowels, which hasn't been done so far. Gujarati language has a very cumbersome data set with around 400 characters. So there would be 400 individual classes, and handling and training on such a large data set becomes very challenging task because Gujarati characters contains isolated as well as non-isolated characters. So we decided to build an CNN to classify this. So this is the basic system level block diagram where we take an input image, pre-process it, segment it, then use classification techniques and recognize the characters. The algorithm for character recognition, first of all, we import the data set and label it according to the classification technique. Either it is multi-label or multi-class classification technique. And we take the input image, pre-process it, apply image augmentation, pass the image through pre-trained CNN model, do hyperparameter tuning to optimize our result, and apply regularization techniques. Then predict output image and compare the results based on validation accuracy and epoch loss to find out best algorithm and classification technique. So first technique of classification is multi-class classification labeling, where we assign each class separately for each character. But as I already said that the Gujarati set contains more than 400 classes. So we would be having 400 output units separately using the multi-class classification technique. And the labeling is as shown in the figure. Another technique which can be used for labeling is the multi-label classification technique, where we assign more than one labels to a single class. Here, the data may belong to more than one class simultaneously. Each data point can be assigned more than one labels, and that what benefits us to reduce the output number of units. And consequently, we can reduce the training time and complexity. So we basically trained our data set on 3 networks: DenseNet 201, EfficientNet B0, and ResNet 50, and compared their results by using 2 classification techniques, that is multi-class and multi-label. And we could see that good performance was obtained in terms of accuracy using multi-label classification within less number of epochs and less validation loss. This is the comparison of validation loss using multi-class and multi-label classification. As we can see, we have trained 3 models. The validation loss has reduced dramatically using multi-label classification, whereas in multi-class, the validation loss has saturated after a certain number of epochs. These are the prediction results of 400 Gujarati characters. We have trained all of these 400 classes, and the best accuracy was obtained 94%.
The presenter, you have last 1 minute.
Using multi-level classification approach. DenseNet 201 provided around 13% more accuracy, while EfficientNet B0 performed better by 26% using multi-level classification. However, training on ResNet was not much change in accuracy was observed. And in terms of validation loss, the DenseNet, the validation loss plummets to quite low value as compared to multi-label, and it saturates at 0.44 using multi-label classification, While using multi-class classification, the initial loss didn't vary much and saturated to quite high value. A similar trend was seen in other pre-trained models. So we have, in our accomplishment, we have tried to include all the consonants as well as vowels in our work, which hasn't been done so far. And due to the large data set of Gujarati script, multi-class classification techniques was not successful in converging the result to an optimized accuracy over the whole data set. So we came up with a new technique for OCR, that is multi-level classification, where we use the concept of assigning multiple labels to single data simultaneously, thus reducing output number of units. And we obtained more accuracy in less number of epochs. This is the summary of our work, in which states that good accuracy and optimized result was obtained using our proposed method over 400 classes with the best accuracy of 94%. And these are all the references which we have considered while working on our project. Thank you. So that was it.
Okay. Very interesting work. Can you just tell me, are there any limitations you faced while using multi-class classification?
Yes, ma'am. Our data set was very cumbersome and we had approximately 400 classes. So using multi-class classification, if we have 400 classes, then we would be having 400 output number of units, and training on such a large network would be very much computationally expensive, and we would require such high-end GPUs for that. And even using that technique, we weren't able to optimize our results. So we moved on to multi-level classification.
Okay. And what was your experimental setup?
As ma'am, we had used the Jetson Nano GPU in order to train our model on.
Can you just repeat it?
We had used external GPU to train our model on.
What GPU did you use?
It was a Jetson Nano 4-core GPU.
Was it paid or was it free?
No, ma'am, it was a paid.
So, how long did your research take?
8 months.
We can move on to next now.
Now we can call our next presenter, Sapan Naik, for presenting his paper on Mango Magnifera Indica classification using shape, texture, and convolution neural network features. Sapan, you may start your presentation.
Good morning. Due to medical emergency, I am currently outside and sharing my, I am not able to share it from giving the presentation on mobile. So I request you to allow Manish Wala sir to share the screen.
Yeah, sure.
Yeah. So Manish sir, can you share the screen? Okay, is it? Hello, Manish sir. Is it visible? No.
No.
Wait a minute. Give me a minute. Actually. Is it visible?
Yes, it is visible. Dear presenter, please, you may start your presentation.
Sorry for the trouble. I think it is visible, right?
Yeah, it is visible. Please
Okay,
start.
sorry. The topic is mango classification using shape, texture, and convolution. Like there are two features that we are using: shape, texture, with we are combining it with convolution neural network features. Okay, next slide, please. The thing is, we know that agriculture plays a vital role in India. There are three phases normally in agriculture: post-harvesting, harvesting, and like pre-harvesting. So our focus will be on post-harvesting. Manisha, can you make it next? Okay, so in post-harvesting phase, if there are lots of scope for automation, please do it next. Yeah, we can. There is a lots of scope of automation. So what our target is to, we are doing classification of fruits as a part of that, because classification is a pre-stage of grading, and grading is currently doing like manually, and it takes lots of time, and it is very tedious, monotonous, and less efficient. So if we apply automation there, it will help us a lot, right? So that's why we have used classification. Here in this paper, we have experimented with mango, as mango exported a lot from Gujarat state. There are different features of mango. There are two types, by the way, for grading: non-destructive, destructive. If you go for non-destructive grading, it would be better. So for doing that, there are different features that you can use: aroma, color, strength, composition, size, texture. These are the features that we can utilize. By observing and by working on this mango a lot, we have concluded that if you want to classify mangoes, that is Kesar mango or Afus mango or Alfonso, you first need to identify their shape and texture. Normally, these two things separate them easily. So we have used that, and due to the advancement in convolutional neural network, we have used that features also. So this is what our task, like work is. Next, please. Okay, so now what is our contribution? We have created a data set of 7,000 mango images. 7 mango categories are used: Afus, Kesar, Jamadar, Rajapuri, Totapuri, Langdo, and Daseri. These are the 7 categories which used widely as far as Gujarat is concerned. These are the popular mangoes, and these are the one which are exported. Okay, now we have extracted CNN feature. As I said, for extracting CNN features, we have used pre-trained CNN networks. There are different pre-trained CNN networks. We have experimented with 5: Inception V3, Exception, DenseNet, ResNet, and MobileNet. Now these are the popular models, so we have utilized it. Now, as you know, you can implement CNN by 2 ways. One is you can use pre-trained CNN and directly predict the output. Second is you can use CNN, pre-trained CNN, extract the feature. Now this feature will be given to linear classifier. So that we have done. So as a linear classifier, we have used SVM, neural network, multi-layer perceptron neural network, and K nearest neighbor to comparison purpose. Okay. Next. Am I make myself clear, by the way? Due to this outside, I'm not able to express it properly, but still. Now this is the flow of the work. There are 2 phases, 2 work done parallelly. All the 7,000 images, like there are training part and testing part, as we all know in machine learning. So during training, we have taken individual image, extracted the feature for shape and texture. Same time, we have created 7 folders with 7 label. We have given 2 pre-trained CNN models, this 5 trained model. We have extracted that feature in HDF file format. So now we are having, after this parallel phase, we are having 2 sets of features. One is handcrafted features for shape and texture. At the same time, we are having feature for CNN also. Now we have combined that and given to linear classifier. There are 3 linear classifiers that we have compared. And at the end, it will predict the output. Comparison will be done, right? Classification will be done. Okay. So this is what the process is. Next. Now, so for shape and texture, these are the features that we have used. For shape, combination of size feature and chain code we have utilized. In combination of size feature also, there are different things that you can utilize, like eccentricity is there, circularity is there, extent is there. So these are the 5 things which we think that relate to the mango much. So we have utilized these 5 things. There are other things also, like bounding box and others you can utilize. But for our case, this will be sufficient as far as by visualizing the shape of mango. Chain code is utilized as it is like rotation and scale invariant. So we have utilized chain code. These 2 things are used for shape feature extraction. Shift, LBP, and GLCM. We have referred some literature review and we have got to know that these 3 could be work based. Like even shift we have utilized to know the shape. The last 2, LBP and GLCM, are used for texture. So getting texture from these 2 is more than sufficient. So that 2 are used for texture. above three are used for shape identification. Last, as I said, for CNN feature extraction, we have used 5 pre-trained CNN models: Inception, V3, MobileNet, DenseNet, Inception, and ResNet, right? Okay, next. So here is the table that shows the timing, because when you give 7,000 images to train to a particular CNN pre-trained CNN model, though you only need to train the last layer of the model, still it will take time. And after that, your whatever features you have extracted will be stored as file, weight file. So here is the size of each weight file, and here is the timing for each and every model to get trained. This is the literal timing that we have started at 10:30 and it will get stopped at 12:49. So I should write 2 hours, but like initially we have write it in this way only. So this is the timing. Okay, so next. Now actually this is the classification. So I hope this is clear. We have extracted 3 sorts of features: shape, texture, and we have extracted CNN features. After all these features are given to SVM, MLP, and KNN for classification. And these are the accuracy that we have received. Almost in every case, the accuracy is more than 89%. It
Sorry
is
to interrupt,
lowest.
sir. You have last 1 minute.
Yeah, it is over. This is the last slide. Please go above. So now by observing this analysis, we have seen that MobileNet was the fastest, and its accuracy is also 97%, which is quite good. Highest accuracy was 98.5%, which is quite good with MLP classifier and Inception V3 CNN model. We have done the same experiment with CNN itself without using shape and texture feature. So currently our results are 4 to 5% higher than our previous result. And by observing the confusion matrix, we have seen that Totapuri has the major misclassification. Now we are trying to work on it. So how, like, why it is so? So that is the case. Okay, next. And this is the conclusion. So we can utilize combination of features. Not only CNN, but handcrafted feature will help a lot in classification. Our average accuracy is 94%, highest is 98.5, which is quite good. The same method can be implemented for multiple fruits. We can go for disease also, and we can classify more sort of mangoes, and we can go in detail for the same. Currently, we are having a software available by which you can upload the image and it will tell you which category of mango it is, right? So same can be implemented for further purpose. Even grading purpose, you can utilize the same. So that's it on my end. Thank you.
Thank you so much, Sapan, for a nice presentation. Ma'am, any question?
Yeah. Sapan, can you tell me the function that you have put in your CNN model?
Hello?
Hello?
Yes, please. Sorry.
Yeah. What function have you used in your CNN? Is it ReLag model or something else?
ReLU, basic or ReLU model.
ReLU.
We have not much tuned the CNN model, which we are already pre-trained available with ReLU function. We have used that only.
Okay, did you try some other function also? Maybe they would have improved your model.
Initially, when we have experimented with CNN itself only, like we have not combined with shape and texture at that time, we have tried with other model, Sigmoid and others. But at that time also only ReLU has given us the good results. So we have not much tuned it. Like, or we have only tuned the purpose for the epochs and others things because the data set increased. Otherwise, we have used ReLU only. Initially, we have tried it, but it didn't give the good results compared to ReLU.
So are you planning to try this model for this detection of skin disease?
Currently, like we again need data set for skin disease, and it is very difficult to get that sort of mangoes images, right, in that much amount. So we are planning to do that, but the data set is the issue right now. It is implemented for classification as well as grading. So currently we are classifying the mango like Kesar, Afus, Dasari, and later on, if it is a Kesar mango, we can identify the Kesar mango is mature, partially ripe or fully ripe, or it is of which size, big size or small size. That kind of work has been already done.
Thank you, sir.
Okay, thank you.
Yeah, that's it. Thank you.
Okay.
Now we can call our next presenter, Satchidanand, to present his paper on comparative analysis of open standard for machine learning model developments.
Hello. Am I audible?
Yes. Please start your presentation.
Sure, ma'am. Let me share my screen. My screen is visible to everyone?
Yes, please.
So, hello everyone. Good morning. My name is Sachidanand Singh, and today I'm going to talk about open standards for machine learning model deployments and comparative analysis of different open source frameworks available in the industry. So, high level, I will touch upon these points. I will start with a problem statement. Why this paper? What is the need of this paper? And then I will talk about different ML models, their types, and how machine learning models are deployed, approaches of splitting data sets into machine learning model training and testing stages. Then I will briefly touch upon the three open source frameworks called PMML, PFA, and ONNX. So what is difference between these three? What are the advantages, disadvantages of using these open source frameworks? So I will briefly touch upon all these points. So before moving on, brief about the authors. I'm working with IBM Software Lab, Pune, as an advanced analytics, business intelligence, and data science subject matter expert. I have authored around 7 patents, 10 IEEE papers, 5 international journals, and 2 books. My co-authors are from TCS and RSL Pune. So let's start. So coming to the problem statement, why the need of this paper? So if you look at the data science projects, the failure rate of data science projects is very high. And as per one of the report of VentureBeat, 87% of data science projects are never deployed on production successfully because of some reasons, which we will talk about. And then another report of Gartner says that only 15 to 20% of data science projects get completed. So what are the reasons behind these high failure rate? So one of the point is lack of open standards for model deployments. Then lack of language agnostic exchange formats. There are unavailability. The open source driven tools are not available in good amount as needed based on the industry specific, domain specific requirements. Then vendor lock-in is a big problem, wherein if a customer is with particular say AWS, it cannot move to GCP or Azure. So this is another big problem. And lastly, deployment process is very rarely discussed among data scientists and machine learning engineers because they consider this as a DevOps stuff, but it is not so. So deployment process is something which needs to be thoroughly discussed and understood to ensure that the overall project gets successful. So in our paper, we are trying to bridge this gap. We have studied some open standard frameworks, and we are trying to present a comparative analysis. And as next step, we are going to pick some company shares data from stock exchange and going to do some predictions and then present like comparative analysis, how movement from one framework to another framework is possible, what are the advantages and disadvantages to give a better clarity to the audience. So now coming to the machine learning models. So what is machine learning model? Machine learning model is basically a mathematical representation of what a machine learning system has learned over time with training data sets. And we use these models to recognize hidden patterns underlying data. So a machine learning model can be consisting of model data and procedure for using the data to create predictions. That is called algorithms. Now coming to the different types of machine learning models available. So broadly speaking, there are three types of machine learning models available: supervised learning, unsupervised learning, and reinforcement learning. So the difference between these three is that with supervised learning, we use label training data set. So model is trained using label training data sets, and during prediction stage, we use unlabeled data set so that it can give predictions. So broadly speaking, we can classify supervised learning into classification and regression types. And KNN, SVM are some examples of supervised learning algorithms. In unsupervised learning, we use unlabeled data. And broadly, we can categorize unsupervised learning into clustering and association. In the third type, that is reinforcement learning, we use agents. So agents decides the best action for a given task in absence of training data set. So we don't use training data set in case of RL. And it learns by its own through trial and error. Now coming to model deployment. What is machine learning model deployment? So broadly speaking, the process of adding a trained machine learning model into an existing production environment to make practical business decisions is called model deployment. So deployment is entirely distinct from our routine machine learning tasks like data pre-processing, feature engineering, model selection, and model training. So this is very critical for any project, any machine learning or data science project to succeed, because unless successful deployment and production is not made, there is no point working on and doing coding and all those steps. So this is very critical stage, and it requires holistic view of end users, how they are going to interact, and how the whole pipeline is going to work in integration to each other. So approaches of splitting data sets. So there are various approaches how training and test data sets can be split. So there are different hypotheses and proposals. So broadly speaking, we split training and test data in 80 to 20 or 75 to 25 or 60 to 40 ratio. So higher the proportion of data
Sorry to
in
interrupt,
training.
sir. You have last 1 minute.
Okay, I will quickly cover. So considering the training and test data set is split, higher the proportion of data in training set, more likely it is to give better accuracy. I will quickly move on to the frameworks which we are touching upon. So we are touching upon 3 open source frameworks, PMML and PFA and ONNX. So PML is an open standard for XML representation, and PFA is a JSON-based format. It supports JSON-based predictive model interchange format. And these two, PFA and PMML, are developed by Data Mining Group, which is an association of association which is managed by Center for Computational Science and Research. And a lot of inbuilt functions are provided by this PFA and this PMML. So there are a lot of inbuilt functions which users can create their own and then do the migration from one framework to another framework. So this is some of the high level points related to PFA. It benefits of PFA. It provides a lot of user defined functions. It provides higher flexibility. Then it provides strong support for traditional machine learning operations. But some of the problems with PFA is that it doesn't provide support for dense and sparse vectors. It doesn't support GPUs, and it doesn't support this generic tensors. ONNX was developed in 2017 by Microsoft and Facebook, and lately it was augmented to support traditional machine learning activities. So again, ONNX is different from these earlier two frameworks, because in the sense that it is not specific to JSON or XML. It can work with any type of data, and it provides interoperability, flexibility among different.
Dear presenter, can you please go with the conclusion slide?
Sure. So lastly, the conclusion. So we are concluding that if we build more number of open source frameworks which can provide interoperability between the vendors, then the success rate of the data science and cloud projects will be much higher. We need to work on language agnostic exchange formats. We need to work on creating more number of open source driven tools. We need to support, provide support for open formats for ML models, and create more number of framework independent file formats. So if we can do that and we can provide all this, the success rate of machine learning projects will be much higher. And in order to succeed any project, any data science or cloud project, we need to understand the holistic view, holistic approach we need to take. And we need to understand high level project architecture as to how different pieces of the project are working. They are integrated within the production pipeline to deliver the business value. So as a next step, we have taken some data from companies' data from stock exchange. We are trying to build a predictive model on top of it, and it will give comparisons like if we use one particular framework and if we want to move from one to another, how it is possible, and what are the different features available with one framework which is not available in another framework. That sort of comparison we will provide it as a next step of this paper. Thank you. Any questions, please?
No questions, sir. Your work is already very good.
Thank you, ma'am.
Okay, so thank you.
Now we can call our next presenter, Swapnil, for presenting his paper on vulnerability analysis of Bluetooth technology for defensive application.
Good morning, madam. Am I audible?
Yes, you are audible.
Okay. My screen is visible, madam?
Yes, your screen is visible.
Thank you, madam. This presentation focuses on vulnerability analysis of Bluetooth technology for defensive application. This is the overall content. So starting with the introduction, Bluetooth technology started evolution in 1994, and it was standardized by a group of companies, Lucent, 3Com, Motorola, Microsoft, around 1998 to 1999. We called this group usually as a Bluetooth specific interest group. As per the standardization, operating frequency of Bluetooth is 2.4 gigahertz with the range of 10 to 100 meters following the Gaussian frequency shifting modulation. Features of Bluetooth are short distance connectivity, accessibility, allows internet access on multiple devices, cost effective than next generation technology. So objective of our research is we perform the research in Bluetooth technology to enhance the security against unauthorized access in sensitive premises such as military base camp, research organization, and other governmental sectors. So preliminary contribution of this paper is we have identified a couple of open source tools. We analyze it for the investigation of services and characteristics of Bluetooth devices. And finally, we design a IoT node mapper, which take the supports of investigated services and characteristics parameter from which we have created a centralized database. And it helps us to map the devices as a result of type and category offline. So this is the relevant work which tells us the necessity of Bluetooth device working. Actually, these all researchers and author worked on fingerprinting of short range communication protocol. So certain essential technical aspects required before the experiment. The essential part only covered in this slide. Bluetooth networks classified as a single piconet, multiple piconet, and scatter net. And it always transmitted advertisement channel initially when trying to connect to other devices. That advertisement channels are 37, 38, and 39. And in the multiple piconet, it maximum support 8 devices. So why we choose the BLE for our research work instead of, there are so many upcoming new generation technologies. BLE is popular, and popularity due to low cost and less hardware required. Like say Zigbee required central entity as a coordinator, Wi-Fi required router as a central entity, whereas BLE is very easy to pair with each other and anywhere. It creates an ad hoc network, and range is also good for short distance communication. So starting with the Bluetooth address analysis, Bluetooth address consists of NAP, UAP, and LAP, that non-significant address part and upper address part combinedly form OUI, that is organizationally unique identifier, which is cumbersome to get on wireless channel at the time of sniffing. But LAP always available in the advertisement packet. We can see here when we perform the experiment, at that time we can easily get the LAP, and there are certain question mark like sign where the upper address part and non-significant address part is not appear. However, with this other information like clock signal to noise ratio and strength of signal is also captured. Now, how to get the information which is related to NAP or UAP? So SCI and GAT tool we have exploited. SCI tool is useful to scan, inquire, and requesting information of the devices, where we can get OUI company address, Bluetooth address, device name, LMP version manufacturer information. Now this Bluetooth address from SCI tool can be further used to target the device. Like say the address we can adopt in the GAT tool, where we can assess the characteristics and services using GAT tool commands. Here we can see certain UUIDs are appear. Each UUID has some significance. That significance is tabulated in this table. We can see the serial number 7, FEE0 and FEE1 is signifies Fitbit band. It means that it is related to the device which categories as a Fitbit or smartwatch, we can say. So in this way, with the combined analysis of SCI and GAT tool, we can map the device. Further, we exploited Blue Hydra, where version of the Bluetooth, nowadays BTLE is the advanced version, Bluetooth 5.0 we can say, address, RSSI, name, manufacturer information and types. Here we can see that manufacturer information sometimes, if it is not available, then how to get that is a disadvantage of this Blue Hydra open source tool. Sometimes type may not get. So here our combined analysis will help.
Presenter, last 1 minute present.
Okay, sir. Okay. So RSSI, with the help of RSSI, we can measure the distance with the given formula. This is our experimental setup, where Raspberry Pi is used with the Ubertooth and BLE dongle with the combined combination of this open source tool on Raspberry Pi, and Bluetooth based devices are kept in the vicinity of the range to perform our analysis. Here we can see that service field is exploited, and the availability of one binary bit in the service field tells us that it is a probably printer, speaker or audio speaker. So using that database, we fed to our GUI, and it tells a correct device using class identifier. So this is our GUI, which tells us it is a wearable headset device, and it is correct. We perform this experiment for this one Samsung based device, and investigated parameter in this GUI is, this is the final outcome for the GUI, that is 16-bit UUID, organizational UUID, 128-bit UUID, and class identifier. With this, we can classify the device. So coming to conclusion, this paper demonstrated the usage of powerful open source tool to exploit BLE technology. Analysis in our research work highlighted that leakage of significant metadata in Bluetooth technology allows to develop centralized database for device mapping. Using centralized database, we develop IoT node mapper, which can recognize variety of Bluetooth or BLE devices. And we can further extend this research toward next generation technology in a similar way. Only packet structure will change, that we have to analyze and feed those database into our GUI. Also, this is the offline research. We plan it for online research, like say, as soon as the packet comes, the machine itself will analyze everything and tells us the device. So these are the references. Thank you.
Thank you so much, Swapnil. Ma'am, any question?
Yeah, sir, can you come on your conclusion slide?
Okay, man. Yeah.
Sir, were there any challenges in using Bluetooth technology?
Challenges in Bluetooth technology is there, madam. Sometimes now upcoming Bluetooth devices are tried to hide the manufacturer information and some other part which required further study to exploit it. And that we have discussed here. Some tools are not able to detect that because that analysis is not covered in that open source tool. So we combine multiple open source tool and try to study that, and certain customization we are trying to do.
Are there any privacy related issues too with Bluetooth?
Sorry, madam, can you repeat the question?
Are there any privacy related issues too?
Privacy related issue is there if the application, it depends on application, madam. If it is used for like say in a military base camp for short range communication, for short time communication, then it will be sensitive. Otherwise, listening music and those things not much sensitive for these things.
Okay, thank you.
Thank you so much, Swapnil, for your presentation.
Thank you, madam.
So we had completed our all presentations, and I sincerely thank our authors for the excellent presentation and all participants for being a part of this international conference. I hope this session was informative enough. All the presenter would be getting their digital certificate within two working days, and we have forwarded all the papers already to the Springer, and publication will be live within 5 to 6 months. And I also thank our session chair for chairing this session. Thank you so much, ma'am, for your valuable time and presence.
Thank you, Richa.
And I request to my team to share the certificate. Ma'am, this is a token of appreciation on the behalf of team ICT4SD and Global Knowledge Research Foundation.
Thank you, Richa.
Thank you so much, ma'am. And dear all, I kindly request to everyone.
Congratulate all the participants.
Yes, ma'am.
Their research was very good, and I was able to see many new arenas of research in the presentations.
Your voice is not clear. Your voice is break.
In fact, I'm saying that all the presentations were done very nicely, and their work was very innovative. So I congratulate all the participants in fact. Like in COVID times, they are doing very well. Am I audible, Richa?
Yes, ma'am, you are audible.
Okay. Thank you, everybody.
So I kindly request to everyone, please turn on their cameras for take a quick snapshot for making this conference more memorable. ये भी एक फोटो ले लीजिएगा दीजिए हम सबका Thank you so much, everyone. Thank you, ma'am.
Thank
Stay
you all.
safe. Take care, everyone.
Thank you, Richa.
Thank you, ma'am.
Thank you.
Richa, can we leave the session now?
Yes, ma'am. Yes.
Okay. Thank you very much.